Personal finance practice problem using Onenote. Future value of an annuity with monthly periods as opposed to yearly periods. Prepare to get financially fit by practicing personal finance. Here we are in Onenote. If you have access to Onenote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side. We're in the Practice Problems tab down in the 1230 Future Value Annuity Monthly Periods tab. Also note, when using Onenote, take a look at the Immersive Reader tool. Our presentations will also be in the text area with the same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got the information up top, calculations on down below. We're looking at that future value of an annuity again, but this time monthly periods instead of yearly periods. As we do that, remember we'll do this with multiple different methods of calculations, some which are more likely to be in a practice type setting, in a work type setting, some more likely to be in a school type setting. The school type setting calculations often being more limited in the way you're going to be calculating, and the tables in particular will have some limitations that we want to keep in mind so that if you're in a school setting, you know possibly what kind of limitations to expect. And then also realize that when you move from a school setting to a non-school setting, you don't really have those limitations if you're using the tools like Excel or something like that to do some of these calculations. Okay, so we have the invest each month. We're going to be investing $1,000 each month. For the years, we're going to say 1.5 years, which means if on a monthly basis, that 1.5 times 12 would be the 18 months. So 18 being the periods. We're going to have a rate of return, which is going to be the 12%. That's the yearly rate. Therefore, the monthly rate is a nice even, 1%, 12 divided by 12 for 1%. So as we go forward, just remember, you got to make sure that you got your time periods lined up properly when you plug the information into whatever format you are going to plug it into as we go forward. That means that you got to make sure that you got the right periods that you're looking at. In this case, monthly periods, 18 months as opposed to 1.5 years. And the yearly rate, which is typically given, unless they say otherwise, they don't typically give a monthly rate because that monthly rate is often quite low and difficult to discuss. But you got to realize that you got to convert it to a monthly rate oftentimes when you do the calculations on down below. This time, let's start the calculations off with a running balance table. This is something that you would often do in practice, less so in a book problem or in a school setting because they're not going to give you Excel oftentimes, but it's useful to learn how to do these running balances. Even with a 1.5 year period here, the monthly tables are quite longer. We'd need 18 periods to copy it down, which can seem tedious, and you can start to think, well, the tables aren't really useful, once you get longer calculations, but they are because Excel can do them quite easily, and they can give you some more insight to do that, even if you got like a 30-year thing, which would be 30 times 12, 360 periods. You could still copy it down within like a minute in basically Excel if you get practiced in setting these tables up. So let's start with that. We're going to say that we got our periods, which are going to go down to the 18 periods. And then we're going to have our increases. We're going to have our payments. The payment is going to start off at the 1,000. Remember that as we do these annuity calculations, the payment is starting at year one because we're assuming the payment happens at the end of the year instead of basically, at the beginning of the year. So if you were in a situation like this and you're saying, well, I want to put money in today, then you'd have to make sure that you're figuring out how to deal with that, because you might have money that's currently in a savings account. You might put another, 1,000 in today and then think about, an annuity calculation that's going to happen basically at the end of each period from that point forward, in which case you might do two separate calculations for the current balance that you have as of time period 0, and then the calculations you'll have in an annuity format at the end of each year. Probably one way to think about it. You can also think about an annuity where the payments happen at the beginning, which we'll talk about later. But note, when you're thinking standard annuity, then the payments happen generally at the end of the period. So year one, the payment happens at the end of the period. No interest is happening or being earned on it for that period one because they happened at the end of year one. And then year two, that's when we got the interest calculation, which we're going to calculate at the $1,000 times the 0.12, the yearly rate, and then I can divide that by 12. That's one way we can do that. That would give us to our 10, or another way we can do it is take the yearly rate, 12%, divided by 12 to get the monthly rate of 1% times the 1,000, also giving us that 10. And we're going to add another $1,000 to it because we're going to have another payment at the end of year 2. So we got the 1,000 plus the 10 plus the 1,000. That means at the end of not year 2, but period 2, month 2, we've got 2010. Then we could do that again. Then we can do it again. We could say the 2010 times the 0.12 yearly rate would give us the yearly earnings divided by 12 for monthly earnings, which would be 20 about. We're going to add another 1,000 at the end of year, not year, month 3. And I apologize if I say year. I'm just used to, I've been doing these and saying year for quite some time, but we're on monthly periods, 18 monthly periods. So then we're going to say this is the 2010 plus the 20 plus the 1,000, and that's going to give us our 3,030. Let's do it 2 more times here. We're going to say then we got the 3,030 times the 0.12. That would be for a year divided by 12 will give us the monthly amount, which will be then the 30. Putting another 1,000 in at the end of year 4. Then we can add that up. We got the 3,030 plus the 30 plus the 1,000 is going to be the 4,060. One more time, 4,060 times 0.12 yearly rate. Then divide that by 12 to get the monthly amount 40.6, about 41, which we can also calculate by taking the yearly 0.12, 12% divided by 12 for the monthly rate of 1% times the 4060, also the 41 about, plus the 1,000 we're going to put in at the end of year 5 will then give us our ending amount, which is the 4060 plus the 41 plus the 1,000, or 5,101. And if we continue that on for, what was it, 18 periods, I believe, months that we're talking here, we get to the 19,615. Now we can verify that by doing that the other way. We would most likely do this in practice, that being with Excel, using a function, looking something like this, equals negative future value. We then have a negative in front of the whole thing to make the result be positive, which you can also do by putting in front of the payment, which might be more proper, but I like putting it in front of the F here, so that's what I do. So then we're going to say brackets, the rate is going to be the 12%, but that's the yearly rate. We need a monthly rate, so we're taking the yearly rate, dividing it by 12, which we just do right in the formula. Note, you could hard code or type in the monthly rate, which would be 1% or 0.01, but if you had a more messy monthly rate, like 5 divided by 12 or something like that, then it's nice to be able to put a fraction into the Excel function, because then it will calculate the exact number here and not have to, the messy decimal won't cause you a problem in that way. And that's one way why, again, Excel quite useful in that sense, that we can use those smaller, messier monthly rates and not a problem. Also note that you have to think about this in a monthly rate. Up top, we did the calculation a couple ways when we thought about calculating the increase or the earnings. We multiplied it times the yearly rate, then divided by 12. Here you kind of got to think about it in terms of taking the rate divided by 12, because that needs to match up to the same format as the periods, which are in months. So comma, number of periods, not 1.5 years, but rather 1.5 years times 12, because there's 12 months, to get you to the 18, which we referred simply to that 18 cell. And then comma, you got the payment. The payment is simply going to be the 1,000. That 1,000 is going in not yearly, but monthly per period. That gives us, once again, the 19,914.75, which is about what we got up top, because we rounded it up here and we got a bit more exact number down below. Let's do it again, this time with our formula, more likely to be done in like a school type of setting here. They might make you do it with a formula. So it's going to be future value equals P, which in this case isn't the present value. The P represents the payments, which are 1,000. So those are the repetitive payments. And then times 1 plus R, which is, this is the new thing. It's not 12%, the yearly rate, but the percents need to match. R and N, in other words, need to match. N is in months. Therefore, the rate needs to be in months. you're usually given the rate in years. You got to take the yearly rate 12% divided by 12 to get the monthly rate of 1% in this case. To n, the power of n, which would be not 1.5 years, but 1.5 times 12, or 18 months, minus 1 divided by r again. R again is not 12%, but 12 divided by 12, 1%. Let's put it down here and build our table out in like a tax return type of format. So we got the payment, that would be in the outer column. And then we're going to be picking in the inner column, which is this top portion, 1 plus r to the n. So numerator 1 plus r to the n, which is 1 plus r, which is not 12%, but 12 divided by 12, or 1% for the monthly rate. And then the 1 plus the 1% gives us the 101%, taking that to the number of periods, or n, which is not 1.5 years, but rather 1.5 times 12, or 18 years, gets us then to our subtotal. Let's do that with the trusty calculator, remembering that you need a calculator that can handle taking something to the power of 18. For me, that means we got to level up. We got to level up to the scientific calculations here. We're going to say 1 plus 0.01 gives us the 1.01, or 101%, to the power of, to the xy, to the caret, in other words, of 18, is going to then take us to the 1.1961475 about. Obviously, it goes on kind of forever here, but back to the normal calculator for us. Science time is over, and then we're gonna say that we take that amount that we just got to minus 1. So minus 1, that'll just give us to that. We could do that in our head. That just gives us the 0.1961475, and so on. So that's this whole thing. Then we could divide it by r, dividing it by r, which is 1%. So let's do that. We got the 0.1961475 divided by 0.01, 1% being the monthly rate, not the yearly rate of 12%. That'll give us the 19.61474765, and so on. And finally, we can take that whole thing times p, which is the thing we started with, 1,000 times 1,000. And finally, we get to the result. We get to the result down here, which is 19,614.75 about. Okay, and note that this amount is what we can use for the tables. So let's do it with the tables down here. Now, the tables, of course, are where we have the severe limitations. So if you're in a school setting and they're going to want to use tables, they're going to have to use, they usually will then default to not wanting to do things in monthly periods, but yearly periods, because that's easier on the table. And when they do move to months, then they're going to have to basically use rates that are yearly rates, like 12%, that kind of distill down to something like a 1% on a table. So remember, you got the percents up top, periods on the left. The periods have been oftentimes representing years for us, but they can represent any period as long as the rate matches the same. So if these are months represented in months, the percents need to be represented in months as well. Note that the percents have to be, to use the table properly, it's got to be, they have to be above 1%. And if you're using monthly periods, then that's not always going to be the case. And they got to be even, which again isn't always the case with monthly periods. It is in our case because we limited that, we use 12%. So remember, that means that, I mean, if they want to use the tables, they're going to have to, and they use monthly, they're going to have to use a yearly rate of like 12% or 24% or 36%, so that they can basically get the tables to be nice and even monthly percents. In practice, it doesn't matter, as you saw up top, because we can do our calculations with a fraction in Excel, and Excel doesn't mind the messy decimal the way the tables do and the way we kind of do if we got to talk about messy decimal numbers. So we get this from the table. We're going to say that it's 12 divided by 12, or 1%, and 18 months. So we got 1%, 18 months. That's going to give us the 19.615. 19.615 right there. It's actually rounded 3 digits, looks like, but even though I took it out to another 0. 1,000 times 19.615 gives us the 19,615, which is slightly different than the 19,614.75 we got up top, because you can see that the table up top, this is the actual number if they were to build the table with this, and it goes on further than 3 digits. which results in a rounding difference between the more exact calculation up top and the more estimated number due to the rounding down below.